Hi everyone, welcome to my channel. My name is Fikret. This video is part of series on Apache Spark Essentials for data engineers. In this tutorial, we're going to learn very basics of PySpark, how to read into data frame from various data sources, and how to persist the data. Let's start by connecting to the compute. So I have selected serverless. But you can run this notebook using your personal cluster as well. So this notebook has multiple sections, and the easiest way to navigate through the sections is to use table of content button. Here you can jump into any sections directly. So let me go back and hide this section. So let's start by exploring the file system, because that's one of the first skills that you need to have when you are ingesting data. So there are a couple of ways to explore the file system. My first command here is using fsmagic. So fsmagic allows to run multiple file system commands, including list commands that you can see here. So list command allows you to see the content of the folder, but there are some other commands like browsing the file content, creating folders, and moving files to copying the files, and so on and so forth. Some of them we will explore shortly. The alternative way of exploring file system is to use dbutils fs command. Just like with the previous command, I am using ls method here, and you can see that output of this tool is slightly different. So in this case it's list rather than dataset. Now that we have our files path, let's start by ingesting the sales data, which is in CSV format. So we can take path from here, but in my case I'm using variable, Python variable, so that it will be easier for you to reconfigure the file path. So my next command here is using read API, and the command starts by Spark session. So again, Spark session is a session variable that available for you anywhere within your Spark notebooks, so you don't need to explicitly create it, although you can create it if you want to have more control over your Spark applications by attaching certain properties. Notice that we are using chain of transformations or methods in this command. So my read API is followed by a format method, which allows you to specify files format. So in this case, it's CSV. And then I'm using load method to specify exact location of the file. Once I have created DataFrame, I can use display command to browse the content of this DataFrame. Let's take a look at the output of this command. So first thing to notice is that Spark has auto-assigned column names to DataFrame, although my first row contains column headers. So we'll fix this problem shortly. Another problem here is related to the data types. So notice these little icons at the top of each column. This indicates data types for these columns. So if you hover on this, it will tell you exact types. And when you are reading from CSV, by default, Spark assigns string data type to all columns. There are ways to change this as well, which we'll see shortly. Now that we have created DataFrame, we can browse its structure using print schema method. Output of print schema is in list format, which contains column headers and the data types. All right, so my next command is similar to what we have seen, except I have multiple option methods here. So my first option method tells to use the first row as a column headers. And then I am asking to infer the schema, which allows you to infer data types in your data frame by inspecting available data in your source. And then I specify delimiter for the file. So in this case, I am using comma as a delimiter, but as you may know, CSV files may have different delimiters types as well. So here is my result. Now we can see that Spark used the first row values as my column names, and my data types are now correct. Ingesting raw files by using infer schema method is a quick and a dirty method of ingesting data. However, it's not the best and scalable way of ingesting, especially if you are dealing with many different files, because for each files we are forcing Spark to figure out a schema. A better and a more performant way of doing that is to specify expected schema. So my next command creates schema variable here, where I specify each column and the data type. And then I am using this variable in my schema method right here. So output result is similar to what we have seen earlier. Once we have created a data frame, the next logical step is to write into delta table. The write APIs have similar structure to read APIs, but it starts with data frames that you want to write to. So in this case, I apply a write API to my DFS data frame, and then I tell it expected target format. So in this case, it's going to be delta. The mode method allows you to specify write mode. By default, it's append, meaning that the data from data frames will be added to the end of your table. However, you can also override target table, which we'll see shortly. Finally, my command is ended with save as method, which specifies table's fully qualified name. Alternative ways of writing in the table is to use save method here. For save method, you need to specify file locations for your table. All right, now that we have learned how to write your data frame into tables, let's take a look at how we can read from delta tables. There are a couple of ways of reading delta tables. So this is probably the simplest way, where I use table method alongside with fully qualified table name. The alternative way of ingesting from delta table is to use SQL method. This is more flexible method, of course, because you can specify any SQL query that's available within the Spark SQL. Spark SQL flavor is slightly different than, for example, T-SQL. By using SQL method, you can execute not only read queries, but pretty much any kind of queries, including DDL, so create table statements, or DML queries. Okay, now that we have data in our delta tables, let's take a look at some ways of exploring this table properties. So describe table command allows you to examine the table structure along with some important table properties. So in this case, let's take a look at the results. So in this case, I'm using extend. You can use describe table as a simple command alongside with the table name, which will bring you only table structure, but with extended keyword added here, you can see some important table properties like table creation time, table location, so on and so forth. Another way of running SQL commands directly from your notebook is to use SQL Magic. So in this example, I use SQL Magic to run the same SQL command I showed a little earlier. In other words, using SQL Magic allows you to combine language snippets from different languages within the same notebook. All right, now that we know how to ingest structured data, let's take a look at semi-structured data ingestion methods. So my next command here uses dbutils fs command. However, in this case, I'm using head method to inspect file content. In this case, it's JSON files representing product data. Like with CSV ingestion, you can ask Spark to infer its structure by using infer schema option. Each data source type has its specific ingestion options, alongside with common ingestion options. So in this case, I am using multi-line option for JSON, which specifies type of JSON that I am dealing with. So here is my output. One thing to notice is that one of the columns has complex data type. In this case, category column is object type with different elements like furniture type, room type, and so on and so forth. Just like with CSV files, you can be more specific in terms of expected schema when you are dealing with JSON files. So in this case, I have created JSON schema variable, and unlike with the previous example, I'm using StructType library objects to specify my structure. So StructType alongside with StructField is a part of pyspark SQL types library, which you have to import whenever you are using it. So this command basically specifies array of column lists, and within this array, each element represents a column with its name, type, and so on and so forth. So notice that one of my columns here is a nested column type. So in this case, you can see we have struct field named category, and then we have nested structure information within that. Output from this dataset looks similar to what we have seen. And my next command writes data frame to the table named product bronze. One thing to notice in this command is that I use overwrite mode when writing the target table, because when you are writing dimension type of tables, it makes sense to either overwrite them or use upsert method, which we are going to explore a little later. All right, that's all I wanted to cover about the key data frame methods. Thanks for watching, and I'll see you in future videos.